Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
And some of those may be characteristics about performance. Some of those may be characteristics about AUPs. And I think one of the themes that has to be prevalent, acceptable use policies, what traffic can be carried on the network. And one of the interesting constraints in our environment is that many of our networks, like the Abilene backbone that Internet 2 runs, has an AUP associated with it. And so how do you get an AUP to be reflected in routing and firewall management and all those other thrills? Well, welcome to life. On campus, we have complex campus networks at this point. There are high-performance sub-meshes in various locations, lower-speed extensions to off-campus facilities. There are clusters of advanced networking activities happen. It is truly heterogeneous. Distributed management of networks and desktops is a euphemism. I don't know that there is management, but whatever there is distributed out there. And I think that's a staple. That's, again, why we represent worst-case engineering. And it is going to be like this. And I had a great exchange this morning with Dinesh about how wild can it get inside IBM Research and Watson Labs in terms of external links, optical bypass, some themes we'll be talking about. It's pretty clear that higher ed is going to keep its leadership in the world of chaos for some time to come. And we have lots of special cases, like medical schools, which want to do their own networking, engineering colleges, which often do their own networking, dormitories where, in fact, we have to drop in packet-shaping devices and other kinds of mechanisms that you may not see much in enterprise networks, but have become pretty legion in higher ed. Residence halls, thank you. We have security challenges. We had a perimeter. I talked about that border router. Well, the perimeter is dissolving for several reasons. Some of you are familiar with the perimeter dissolving because my laptop was in Starbucks last night and its health is now to be questioned. And that's one of the erosions of perimeters. But there's many other, and that's a very common erosion that the corporate world faces as well. But we happen to have pretty distinctive erosions around that as well. We'll be talking about all the optical bypass that people are thinking about. Jim Pepin has a wonderful word to describe optical bypass. It's really not about performance. It's really about friction-free networking. And we represent friction. The institutional enterprise policies represent friction. We have large numbers of roaming devices, the wireless stuff that we've talked about. Slow to deploy DNSSEC and problematic IPsec, though I would say that higher ed is now stepping forward as the first coordinated community to deploy DNSSEC on a wide basis. We'll find out what those experiences are shortly, but we are deep into the Shinkuru, Kool-Aid, and other activities associated with that. The prospect of new types of external non-IP connections. Again, a lot of the optical bypass is IP. Some of it is not intended to be TCP/IP. What is that going to mean? I'll get back into the complex undiagnosable deployments. In a bit, you'll hear from Mark and Chad later about some of our efforts at boiling the ocean of diagnostics. Nothing less than that. And then lastly, we have policy drivers for technology. I think, in fact, I would say at this point on most universities, policy is trumpeting any piece of technology sets of issues. And if I'm faced as a CIO with having to give you performance or security, it's no choice, Scarlett. Sorry. Going forward, opportunities. So the prospect of on-demand personal lambdas. This is really something that has gotten a lot of motivation in the last few months and years. Whether it comes from an NLR environment or from a NewNet environment, I think almost all of higher ed is planning on provisioning in some dynamic fashion, and the time frame around that dynamics is going to be interesting, lambdas on demand. And what that means directly to a desktop or directly to a lab, and what that means is a dark future, to use a bad pun. InfoCard. The fine people at Microsoft are giving us some new capabilities. We've been deeply engaged with the crowd at Microsoft doing this. We ourselves have kept out of the peer-to-peer trust fabric that InfoCard represents. We've been more in the federated space that I'll talk about in a second. But InfoCard and the identity metasystems offer nuclear opportunities to us in terms of network management. And if you haven't seen the InfoCard demos, they're killer. They really are. And they give users capabilities that perhaps in the consumer marketplace might be okay, but boy, in the enterprise marketplace, to have users have these capabilities of managing their desktop firewalls, managing perhaps downstream firewalls, gives us some interest. Federated identity and trust. So the space that we've been working in a lot recently in the last 4 or 5 years is around federated identity, and it's become a buzz phrase, and it's really widely out there. And think of it as enterprises doing local authentication and authorization characteristics and exchanging using hopefully SAML, but at least SOAP messages between enterprises, and then building those enterprises into federations, and then peering those federations. And if this sounds like a flashback to BGP, it is. And it's one level up in the protocol stack, and we go back frequently to Scott Brim's ideas about BGP to figure out how we're going to do peering. And I was on a phone call this morning at 7 a.m. with the federal government because we're about to create peering between a higher ed national federation and a government federation, and exchange assertions along the way. That's a tremendous amount of capabilities that I think we need to look at. One of the phrases that Dave Clark uses a lot to describe Genie is that it will have to have trust-mediated transparency. That is the ability to create a clear wire between 2 points using trust as the way to manage the transparency of that connection. The data to drive the motivation for transparency will come from either an InfoCard context or a federated identity context, and we are working with Microsoft to see if those can be unified, at least in the presentation to the end user, so that when screen 3 in Vista pops up, all of your enterprise InfoCards and your personal InfoCards are sitting there in front of your eyeballs for you to manage your trust relationships with the external world. We face very uneven economics continuously in this space. And so it means that any plans that you can create are going to be good at most for the lifetime of your contract, but probably not even that. And so we'll come back and talk about that, I think, in the anecdote space. A couple of other points about our space. We represent an enterprise-centric viewpoint. Networking is part of an infrastructure provided to the members of the community. It's operated often as a common good. That means we do not have mechanisms for managing bandwidth and controlling bandwidth that are at least operated by a financial basis. And that takes away one of the tools in the kit bag, but it does leave other tools. That said, it's enterprise-centric, but only often to a point of presence within a building. And then we turn it over to the departments within that building. Often, if there's just one department, they can pull it off. If it's several departments within a building, they often discover the thrills of running network management for distributed environments. Desktop autonomy. So it was interesting to hear the questions earlier about, gee, how does this model-based approach to network management work for all of those machines that may not be running Microsoft or may be running old versions of Microsoft. So I trust you have the Windows 98 versions of all this stuff done as well. Because we have Windows 98 on our campus, and they're hard to get rid of. We have loose desktop management. You know the euphemism. You've heard it before. We are leading edge. We are early developers, adopters, and infectors of new technologies. And then I think lastly, perhaps somewhat uniquely, we have regulatory complexity. So we spend a fair bit of time trying to understand what HIPAA means on the wire, what HIPAA means at the desktop. And Lord knows there are no definitive answers to either one of those. FERPA is a set of requirements that is somewhat related to HIPAA, but they apply to the data that a student provides to a university and what protections are there around that. And we have privacy spills that used to be considered fairly big to the Veterans Association. Veterans Affairs came along and really showed us what the government can do in this space. We have AUPs, as we talked about, and then now recently we have the Digital Millennium Copyright Act, which places new constraints on the traffic that we run on our networks and what our responsibilities are relative to that. And it's a thrill. We also have demanding applications. So all of the network management devices that we'll be talking about over the next day and a half better not mess with the bandwidth. Better not mess with the jitter, latency, etc. I think of all of those requirements, the one that is the most vexing these days, but maybe we'll hear differently from the actual product development side, is the transparency sets of issues. And I'll talk in a minute about two anecdotes in that space. We have strong interinstitutional requirements. One of the phrases that we'll be talking about when we talk is these virtual organizations. The virtual organizations are intuitively that group of scientists doing that particular satellite or that particular large hadron collider at CERN. What we're seeing, again, in the corporate sector is that once you point out the existence of VOs, they go, yeah, we got them by scores. We got Intel and Microsoft working together on a project. Wouldn't it be nice if instead of giving all of those Microsoft employees accounts on this Intel server, we could do federated identity along the way? That kind of stuff. So, again, I don't think higher ed is in general as distinctive as much as we are early. And so when we talk about our needs, the federated identity is a good example. It was a natural to us, and now, aha, the Burton group, or the Gartner group with probability 0.9, believe that federated identity is here to stay. I think that's how they would word it. We have multiple external links. We talked about some of those issues. We have a funding paradigm in higher ed that favors one-time versus continuing costs. You land the grant, you got the ability to buy the circuit, but gosh, who's going to maintain it over time, etc. A lot of acquisitions of hardware are one-time dollars. Where's the maintenance money? So we once thought we were unique, and then we've seen a number of publications that are saying we're just early, but we're not unique. And one of those is the Jericho Forum, and they state that you can no longer assume that an organization owns, controls, and is accountable for the ICT infrastructure it employs. So listening to the earlier talk this morning about a model, my question was, how many models, and how do the models relate? Because, in fact, it isn't going to be the single monolithic enterprise that we'd like to believe. You should not assume that all individuals sit within the organizations and are managed by a single identity management system. In fact, we're having an interesting conversation now in higher ed about whether or not you don't get your primary identity from Yahoo when you're 7, and that we somehow cascade off of that versus doing our own identity proofing, etc., going forward. Maybe our business is supplying acts of authentication or maybe even attributes about individuals, but not necessarily being the vetting point for identity in the first place. We'll see how that goes and plays out. So the vision statement from the Jericho group says cross-organizational security processes and services. This is going to be an important theme going forward, at least in the higher ed space. We've opened up a new door in the last few months around collaborative security analyses. And I'll talk about this in a second, but we have a project that we're doing on shared darknets, where we're trying to, every campus has a darknet, every enterprise has a darknet. What happens if we start to pull data together from a variety of different darknets? What is the wide aperture statistical analysis that can be done? I'll come back to this in just a second. open standards, and assurance processes that used in one organization can be trusted by others. The conversation with the feds this morning was about how our identity proofing activities can be satisfactory to the federal government, let alone this federal government. That said, there is a lot of room for agreement on this, and there's anecdotes galore about how we're finding common ground in our identity management procedures going forward. But again, this premise that external sources of authority will deliver assurances into a service provider or a resource provider is just a given going forward in our minds. At least we hope so. Another corporate group, just so you know this isn't higher ed ranting by itself, is the Network Applications Consortium. It's a group of 25 to 30 major companies with intermingled research and operational environments. I think that's another characteristic of higher ed, is that we don't have research sitting off in Watson and everything else living in a sanitized environment. We have research scattered throughout the enterprise, and almost every network can be guaranteed to have important administrative traffic as well as a wild hair of a researcher on there. We can try to diminish some of that stuff, but there's limits to what we can do. So there, the Network Applications Consortium talks about membership radically improving the delivery of agile IT infrastructure in support of business objectives. Their original focus was on middleware, but they've now opened up a whole wing in the network security space, and I would just commend this URL to you. They're good people. Here are some of their concepts that we also live by. Security by design, usability as well as manageability, defense in depth, simplicity and enforced policy, and then their key leveraging technologies include identity management, and I was having a conversation with Mark offline about how network access control is the new domain of identity management. It is just, and then when you start to deal with the Europeans on that, all of the privacy requirements that we just saw bubble up with the FAA activities bubble up here as well, and so it is not only identity management, but it may be attribute management, so we can manage the privacy requirements along the way. Directory services, border protection, reusable tools, desktop management, and role-based security is at the bottom of the screen. So just a couple of things with the commingling, and then two anecdotes, and then turning it over to the crowd. We live in a hybrid world. The commodity internet is part of the R&E network environment, but it's not the only part. So the commodity internet brings with it its security issues. It's packet disruption appliances, a phrase that I first heard from Terry. It's when you have liquid magic sitting on your network as an appliance. And liquid magic, or is it audio? I think it's liquid audio. Audio liquid. Put those words together. What the appliance does is it looks for signatures of copyrighted songs. And when it finds one of those being exchanged, it issues a TCP reset, effectively stopping the transfer. But creating a TCP spontaneous reset in the middle of this mix, that would cause a network manager to go, what's happening here? Well, somebody dropped a box in on an appliance, a packet disruption appliance. And the appliance certainly doesn't let us know it's there, except by these spontaneous acts of network violence. We have legacy requirements as well that the commodity internet provides to us. True to being the original crucible, new deployments in commodity often begin in R&E, and as we've had a fair number of deployments of multicast in the R&E network, far more than in the commercial sector. We have a fairly extensive V6 development because NATs don't work well for us. And DNSSEC, as I indicated, we are now moving aggressively forward in the DNSSEC space. We're also commingled with the future. Anything that Genie crowd does is going to land first on our campuses, because those are the researchers they're looking for. We also recognize that the forces are out there that may drive management of long-distance networking to the endpoints. Again, if you believe in optical bypass, if you believe that these researchers somehow got funding or permission to have a lambda between Carnegie Mellon and University of Washington, and those land at endpoints on the campus, not at a border, how do you manage that? Where do you put the firewall in that case? Is this a back firewall to stop that rogue machine in the department from getting out into the rest of the campus? Do we give you good performance to Carnegie Mellon from the University of Washington, but don't expect your email to work well because we're routing your email that way as well? We'll see. Layers of invention that new networking approaches could leverage are being developed in the R&E community. So we're having interesting conversations about manageability. And as I indicated, we feel like we're at the forefront of the trust fabric business. So we talked in our workshop in October about architectures more than protocols. And I think this is a conversation more about architectures than protocols. We have steep requirements around policy, whether you could find a gratuitous XACML expression of that policy that was actually a valid XACML expression of that policy that you could test to see if it was valid and that you could then apply it somewhere in the network. I don't know if we're there yet. We're driven by researcher needs as much as by economics, capabilities, security, policy, etc. The research community has inordinate sway on our campuses. So I want to close this part with a set of questions that we posed to the workshop in October. None of these questions got answered then. I hope they can all get answered today. What is the role of the enterprise versus the role of this virtual organization versus the role of the individual in authentication, in authorization, in provisioning, networking, in resource discovery, etc.? Most scientists barely acknowledge the campus that they're on, but are deeply passionate with the VO that they're a part of, and they're ultimately individuals. And so that dynamic and that tension runs our lives. What role will the enterprise have in personal lambdas? What parts of the infrastructure will the enterprise own and manage? What really matters in manageability? I think one of the things that we discovered is that what's important for us in manageability is not what network management researchers are doing, and that's part of why Dave has brought this together. So costs matter, downtime matters, security matters, privacy matters. Gee, I didn't see anything there about quickly provisioning circuits on a 2-second delay for some purpose. So our sets of issues may be different for manageability than what is being viewed today in the research community. Does the control plane, data plane distinction continue to matter? Boy, I think there's a perpetrator of, I don't know if you did directory-enabled networking or you tried to run from it. Okay, okay.
Not all.
Maybe the fellow next to you. I look at the Cisco crowd because, yeah.
No, directory disabled networking came from the people that were doing the work that was talked about in the keynote.
I'm going to let that one sink in for a second, Fred. So yes, remember dynamic networking. Remember all those interesting ideas. Aiken was, you could make a case that he was ahead of his time. You could make lots of cases about Bob. But one of them is that we didn't have directories at the time, so to talk about directory-enabled networking was a little early. We now have directories. We have directories that we count on day and night that can provision attributes at a moment's notice, can sign those attributes, can do all kinds of nice things about them. Should we step back into that dark space of directory-enabled networking at this point? How will diagnostics happen in the face of complexity, higher levels of performance, scale, etc.? You'll hear from some experts in that space. How will resource discovery be addressed at so many different layers? Everybody does resource discovery. Everybody does it differently. How important is end-to-end transparency? How important is innovation in the face of security? Again, most campuses are moving to buckle down. I can just tell you at Johns Hopkins, where they turned off a grid FTP transaction Because they thought it was a distributed denial of service attack. True story. It did.
Using the network, God forbid.
Well, and the data had the same quality that a DDoS attack had anyway, but let's not go there. What will drive the changes? How will networks and devices and appliances on the net change the problem? What is it going to mean when all the Palm Pilots of life out there are IP enabled and can do viruses? You all know about spam now on SPIM, I guess it's called, or SPIT, right? Spam on internet telephony. What are we going to do about these devices, and how will outsourcing, offshoring, et cetera, affect R&E networks? So I want to end with two specific examples of what we would welcome researching. The first is around what I'll call, get this right, dynamic firewall port management protocols. I recently reviewed a proposal for the Department of Energy that I strongly recommended not get funding, so it did get money, $15 million, to develop a mechanism where you would present a certificate issued by a CA you had never heard of before to a router on your campus manufactured by a vendor that you didn't talk to, operated by an enterprise that you haven't had conversations with. And the assumption was made that by presenting this certificate to a nest of firewalls, you will get transparency. And this got funded. So sometime in the next 2 years, I expect to see certificates dropping into Cisco boxes to be processed through long path validation processes with lots of CAs that forget to do certificate revocation or anything else meaningful to open up a port in a firewall. Well, I think we'd like that capability if we could manage it, or we'd like to at least see what it would look like in a managed environment. If somebody could do that, hopefully by the end of today, we'd be thrilled. The second one is a space that I believe is just opening up that's going to be pretty exciting. And it's around collaborative security processes. And so that shared darknet that I was talking about, going back to it briefly, those of us who are doing some degree of perimeter protection against attacks often use signature-based approaches, which work only so well when encrypted attacks begin to arise, and that's what's happening out there in the world. Many attack vectors are increasingly encrypted. So what we'd like to do is to move from a signature-based only mechanism to one that used a lot more statistical analysis by pulling together shared darknet data from a variety of different enterprises. We picked darknet originally because it has no policy barriers. By definition, darknet data or darknet activity is malicious, and so we don't have to worry, can I share this kind of data with other enterprises? So we're starting to look at mechanisms that would pull darknets from 150 universities together, do an analysis depending upon the wide aperture aspect here, to come up with a better set of statistical analyses of the attacks that we're seeing. And I can point people to some of the documents associated with that. As we start to think about that approach, one of the first questions that came up is, good Lord, we're going to need a lot of compute power to grind this data. Net flows beyond buckets. So are there algorithms that are analytic algorithms to analyze this data that hopefully the algorithms themselves could be distributed fairly close to the data so that there's a mesh of what data I have and what my algorithms are doing, and then somehow I forward some of the outputs of those algorithms to a centralized facility that might do some pattern matching. That's an incredibly productive area that has had no activity to date. So what we envision going forward is the University of Colorado subscribes to a shared darknet service. We provision darknet data to a centralized authority, but we also create some degree of localized computational resources perhaps in a grid, though I twitch when I say that word, so that you can do some of the computations locally and pass up the results along the way. Now, I don't know that there are any algorithms working in this distributed space, let alone algorithms that would respond to localized, optimizations versus global optimizations. I believe going forward, this is going to be a very exciting area for work. I'm catching at least one graduate student nodding his head up and down. And please see me afterwards to give you the URL for this, because I think there's a lot of potential there. So those are some examples. I'm going to shut up now. I'm going to turn first to Terry, who's going to give substance to what marketing was saying, or maybe something else.
Okay, thank you, Ken. Before I get started, I wanted to just comment on a couple of things Ken mentioned. First, for historical correctness, the very first ARPANET IMP was installed in the UCLA Computer Science Department over Labor Day weekend in 1969. But I didn't start the PhD program there until 1973. So my fingerprints nor my signature are not on that one. However, I did become an early user of that IMP and have, in fact, been an email junkie for over 3 decades now. The other thing I wanted to comment was the differences between research universities and industry, and whether or not we are different or just early. I think there's some of each. I usually think of our place as having the same IT problems of any other multi-billion-dollar a year enterprise, except that we also operate a couple of hospitals and we have 45,000 students wandering around. Oh yeah, and we do some classified government research and a few other things. So in some ways it's sort of a perfect storm of constraints between regulatory and different needs. I often think that it's best to think of a research university not as a coherent entity, but as a federation of 1,000 principal investigators, all of which are independent business units, and all of which have both resources and strong egos and a very intense desire to get their work done. And residence halls, yes, right. So one of the distinguishing characteristics of a university is that the middle name of every academic unit is autonomous and proud of it. Some universities are merely aggressively decentralized. Some of them are militantly decentralized. But there is a lot of lack of top-down central control. The other thing that I think continues to be something of an important difference between universities and industry is the point Ken made about funding. There is an emphasis on one-time funding. And one of the consequences is that we don't tend to have technology refresh depreciation funds widely deployed. And so in the university of 1,000 years, we end up with technology from each and every one of them still running. And that is, I think, a little bit unlike many of the industrial situations. So with that, let me jump into the comments I had prepared. I've got a lot of ideas I want to throw out. There isn't time to go into detail, but I hope that you'll be able to latch onto a few and maybe come back at a break or the panel discussion and ask more questions or give us some feedback. Now, it's been a lot of years since I've actually done any real research with a capital R, but I wanted to get into the theme of things here. So I was thinking about a song that Sheryl Crow wrote that car companies like to use in their ads. It includes the line, "Every day is a winding road." My version of that is every day is a research experiment, because you never know whether or not it's going to come out the way that your model predicted at the beginning of the day. So with that in mind, I think of the experience that I have involved in operating fairly large institutional networks, and we also operate the Pacific Northwest Gigapop, which is the crossroads for high-speed RNE networking in the Northwest, and we design and operate the statewide K20 network. From that perspective, I think there are some lessons that could be useful for this discussion. And I want to start with some questions for you folks. My first question is, have any of you seen any 404s lately that go away by themselves a minute later? You go to a web page, you get a 404, you try again a minute later, and it works. Anybody seen that? Do you think the trend is getting worse? How many think it's getting worse? How many think it's getting better? Okay. Let me ask this. What's the maximum retry count for TCP in MS Windows? Anybody know? I believe it's 5. And it's based on the round trip time calculation. So if I've done the math right, if you have what I would think would be a rather large round trip of maybe a half a second, that means that you're going to give up after 15 seconds. That's kind of not very long when it takes on the order of 5 minutes to reboot a router, maybe 2 minutes to reboot a switch, maybe 30 seconds to download a config. Even if it's maybe 10 millisecond round trip time, that 310 milliseconds before you give up isn't a lot. So that's an interesting research question. Do you think there could be a correlation between that design decision and the phenomena of 404s that go away? I don't know. But I think it's an interesting question. All right, so I have a thesis or several theses here. One of them is that the open internet died in 2003 at the hands of Slimer and Blaster. You may have seen the news at 11 o'clock on that, but the internet did die. The drawbridges went up. There's no sign that they're going down anytime soon. I'm old enough to remember when networking was really about connectivity as opposed to about isolation. But today it's about selective isolation. Ken talked about that a little bit. I do worry about the fact that we seem to have both an increasing tolerance for and an increasing frequency of these glitches, like the 404 phenomena. So I use the phrase mean time to glitch in that context. It doesn't seem like that's getting better. So my conclusion is that the current internet model is kind of busted. There are lots of silent failures because of these traffic disruption appliances that Ken referred to, and we don't really have very good diagnostics. Wouldn't it be great if the router vendors could actually tell us real-time information about a particular flow and what packets it was throwing away relating to that flow, as opposed to just aggregated counters of drop packets? If you're on the phone in the NOC with an irate customer, you want that real-time information on a per-flow basis, but you can't get that today. You can get a lot of information about the successes of a router, all the packets it successfully delivered, but try getting detailed real-time information about the stuff it throws away. Okay, some buzzwords.
Aaron, can I ask you?
Yeah.
Go back to the slide. When you say silent failures, how do you determine that they are happening?
How do I determine that they're happening? Well, usually because somebody complains, right? And we'll touch on that again in a minute. But a typical policy enforcement point is going to block traffic. The user calls the NOC and says something's wrong with the network. There's no feedback to the user. There's no interface at that layer of policy enforcement to the people that need to know. And so they report it as a fault in the network. I consider that busted.
So silent, there's a thud, something didn't work, but whoever sort of caused the thud didn't really say anything about it. Somebody threw a packet on the floor because they figured it was a bad packet, so they're not going to tell the person who generated the bad packet that it was bad.
So
that would be bad.
So it's sort of like anecdotal evidence, but not really
It's users not being able.
Not being informed.
Edu domain can't talk to the military anymore because Milnet is blocking Edu.
Or they will in about 30 days.
About 30 days.
Because they've declared that all .edu traffic is inherently insecure. So their solution is to block traffic from .edu.
And you see a lot of this stuff.
Well, we have all kinds of arcane problems that are very hard to diagnose. If this 404 phenomena had happened 5 or 10 years ago, we would have scurried around and tried to do diagnostics and instrument things and tried to figure out what was broken. Now it happens so routinely, and there's so many potential causes you don't even try.
I've given up trying to tell people on our campus, stop using the word glitch. It's become, everything's a glitch. There's no longer a problem anymore, it's a glitch.
Yeah, for me the difference is how long it persists. Right? Okay, moving right along. Some buzzwords that I think are important. This top one should be trust-mediated transparency. I left out the transparency. Ken already mentioned that. The next one, convergence, virtualization. If you're a server guy, you talk about virtualization. If you're a network guy, you talk about convergence. If you're an operations guy, you look at that and you scratch your head and say, well, let me get this straight. This means that if one box fails, that all of these services go down at the same time? Help me understand why that's a good thing. Right? And I remember having exactly the same reaction when someone first explained to me about directory-enabled networking. Okay, a few things I'll just throw out here. One is the perimeter protection paradox. That's the idea that the value of a firewall is proportional to the number of hosts it's protecting, but the effectiveness of a firewall is inversely proportional to the number of hosts it's protecting. Because one way or another, as the population grows, one of them is going to get infected, and then you've got a worthless firewall. Remember the good old days of the network utility model where you had an Ethernet jack and they were all the same? They had the same semantics, just like the 110 AC outlet. You didn't have to worry about how one differed from another, especially in real time. Those days are gone. But that really makes a difference from an operations point of view. Think about the concept of defense in depth as juxtaposed against mean time to diagnosis. How long does it take you to figure out what's wrong in a network? I claim that mean time to penetration and mean time to innovation and mean time to diagnosis are all proportional, and they're all proportional to some power of the number of layers of defense you have, of perimeter defense. So, for example, if you say that defense in depth is good because it makes the mean time to penetration maybe the square of the number of layers of defense that you had before, then I would claim that is also going to have the same effect on the time to innovate at the protocol application level and the time to diagnose problems when things go south. So there are trade-offs here. You need to understand the trade-offs. And finally, how many arbitrary policy enforcement points do you need to have in a path before the overall system becomes non-deterministic? The answer is one. And think about that one as a router that just took a certificate from some unknown source and decided to randomly turn on ports or turn off ports. Right? It doesn't take much to really ruin the life of somebody in a NOC. Here's some trends that I see. Software-defined networks. I don't know if AT&T trademarked that name in the 70s or not, but anyway, we see this very strongly in the conversations that you heard from Ken and others, that there's going to be a lot of real-time or quasi-real-time or short lead time configuration of circuits, of paths. There's the option of having arbitrarily complex routing protocols based on any parameter you can imagine that are starting to show up. Change your normal default routing protocol of choice to incorporate things like diffserv and identity management information attributes, and you route differently based on those things, or what time of day it is, or whether you're talking to .mil. And you have a really interesting problem of trying to diagnose what's going wrong. Another important trend is this personal lambda thing that Ken talked about. I urge you all to think carefully about why is that happening. Is it just because there are high-end physicists that don't want to play in anybody else's sandbox? Or might it be that they have a legitimate concern that maybe the shared packet infrastructure that we've all grown to love and to rely on isn't meeting their needs? And if not, why not? This is an important trend and needs to be understood. Another one is the tunneling through firewalls by using tunneling over port 80 or 443. You can find shrink-wrapped software now that says firewall friendly. which is code for I tunnel over port 80. Another clear trend is encryption. The trend is strongest in the sub-rosa world of people that don't want to have their traffic discovered. When I'm in rooms like at tech advisory board meetings at vendors, and there are a bunch of CEOs from industry around, you can get a really good argument going about talking about whether end-to-end encryption is a good thing or a bad thing. Half of them will say it's the work of the devil, we have to get rid of it, we can never allow it because we can't manage our network, we can't see what's going on. The other half says, well, obviously you have to have end-to-end encryption. How else are you going to secure the streams, right? So this is an interesting area as well. Endpoint firewalls dramatically change the diagnostic picture. When you can't ping a host, you lose important tools. And now that for security reasons, ICMP traffic is often blocked, so you can't use traceroute or ping to diagnose a path in the traditional ways, you're left pretty blind when you're trying to figure out what's broken. There are more and more of these policy boundaries. They're arguably less effective as the tunneling and the encryption kicks in, but they haven't completely gone away, notwithstanding the Jericho group's declared manifesto. And as Ken talked about, regulation and compliance is a really big deal. For example, how many of you know what CALIA is and the recent CALIA stuff? Decisions are going down. I don't think anybody knows what the impact of that will be. And it's not just higher ed that should be worried about it. Every corporation should be worried about it because they're all going to be in the CALIA business if the prevailing interpretations hold. And we don't know whether that means everybody has to do authenticated network admission control so that you can respond to a requirement to provide all the traffic that has anything to do with Fred Baker or with Terry Gray or whatever, as opposed to just all the traffic associated with a given IP address. So there's a lot of questions there. Now, yes?
What about IPsec and IPv6?
What's your question?
Well, sort of endpoint firewalls, we were thinking, if we instead of push towards end-to-end, about IPv6 and IPsec, isn't that sort of like a better way to go about it? And then if we do, then what happens to diagnosability? Because everything is encrypted and we can't
That's my question.
So is that what you mean by the endpoint firewall thingies?
Yes, well, and encryption via IPsec and encryption. That's exactly the kinds of things I'm trying to point out. Yeah, so obviously if the stream's encrypted, it's hard to put a sniffer on it and figure out what's going on, no doubt. Okay, with condolences to John Lennon, just think about this scenario. Imagine being in the NOC with an irate customer on the phone. The customer says, is the network broken? And the appropriate NOC response is, I give up, is it? How would I know? Do I even have tools available to me that can tell me whether I've got a network problem or a host problem today? I refer to that as the famous finger-pointing tool. It doesn't exist. So how are we going to answer this question in real time in a satisfactory way? So here's some of my hard problems that I'm listing for your consideration. Distributed denial of service, notwithstanding Tom Anderson's efforts and probably others in this room, I think we can agree that's still a problem, as the Blue Frog people found out recently. Worsening mean time to glitch, if indeed you accept that premise. Diagnostic complexity and the impact on mean time to diagnosis. Provisioning complexity, and think back to the golden days of all Ethernet ports had exactly the same semantics. Compare that to what we have now. Mismatch between the best and what is a common deployment. Think in terms of TCP retry counts. Think in terms of duplex mismatch debacle in the industry standards process. Think about stack tuning, the Web 100 effort, and trying to get all the TCP stacks so they can auto-tune and perform better. The studies I've seen, the percentage of hosts that are really tuned for performance to get what the links are capable of is embarrassingly small. What about path policy discovery? We don't have the policy equivalent of path MPU discovery. So that goes with the silent failure problem. If there's a firewall that's blocking a port, how do I find out about that so that the user doesn't call the NOC? Trust management, Ken has talked about that at some length. And again, this issue of policy enforcement tends to be silent from the user's perspective. And so the consequence is that to them it looks like the net is broken. So I consider that a broken architecture. Continuing with more hard problems, managing heterogeneity. Obviously, there are different bugs and different implementations. As I mentioned, we have technology, versions of operating systems, and transport stacks from many eras of history. There are different conventions, jumbo frames, and I'll point out that the guys who want to do personal lambdas are also the ones that are not interested in 9 kilobyte jumbo frames. They want 9 megabyte jumbo frames. So, there's a whole different mind space out there. What about organizational versus geographic topology? Should I be able to provision the English department as one cohesive, semantically equivalent network with a single firewall policy, for example? Or should I make it easy on operations and just do the normal geographic topology and you're on whatever subnet happens to be closest to you? Conflicting needs. How do we scale personal lambdas? Right now, we'll probably do it with a lot of dark fiber, but is the future to have multi-service provisioning platforms in every corner of the university so that we can rip off a 10 gig lambda for somebody in a nearby building? I don't know. As we touched on earlier, the problem of managing and diagnosing in a world with end-to-end encryption, dealing with exceptions, whether it's a firewall rule exception or an ACL exception. How many of you have looked at a set of ACLs on a router 5 years later and said, I wonder what that one was for? Why did we put that rule in? How do we manage that? And what kind of glitches might that be causing that maybe are unknown to operations? It might be the user saying, oh, that damn network just doesn't work. But they might never report it. Seduction of more protocols and more complicated protocols. Being able to have more flexibility and more choice in routing or other technologies is a two-edged sword. Flexibility usually is. What about attribution versus anonymity? In the CALIA context or other law enforcement or other types of situations where you can make a good argument for the importance of anonymity. In some cases, you can make a good argument for being able to have attribution in other cases. What about multicast fault containment? 20 years ago, we all had big flat Ethernets, and we learned about broadcast storms, and we learned about, Tank Wars, which was a UDP-based game that did UDP broadcasts and brought down the network over lunch when people were playing it. So we started putting in subnets that provided natural fault containment barriers to broadcast traffic. What's the moral equivalent today for multicast? HP printers have multicast enabled by default. And if you cross-connect two switches in a closet, it doesn't take much multicast traffic to start a loop that can cause serious problems for an entire network. I speak from experience. And finally, optimal fault zone sizing. A current debate we're having and have constantly over the years is, do we have lots of aggregation in a small number of boxes, or do we have smaller boxes that if they fail, you're only embarrassed a little bit instead of a lot? It's like if you're going to go down in a plane crash, would you rather be in a Cessna or a 747? Well, to you, the passenger, doesn't matter. But if you're the president of the airline, it matters big time. So there's these kinds of debates. Is there a science behind the size of elements and how big a fault zone should be? These have political components as well as MPDF calculations behind them. So it's kind of hard to analyze, but it's a really important day-to-day design decision that we face all the time. That's it. Plenty of work to do. We need your help. I'm hoping some of these current problems can help inform the future clean slate proposals that we'll be hearing about.
So you talked about a whole bunch of problems. I was sort of wondering, have you thought about the distinction between the wireless space and the wired space? I mean, do you think there are some problems which are different in the wireless space?
I do think there are problems that are different.
Deal with now that you didn't have to deal with earlier?
Yes, I think that the diagnostic problems in the wireless space are much worse, and they were already not solved in the wired case, so I'm worried. With respect to security, which is what you might expect the answer to have been, our policy has always been there is no network that should be trusted for anything. If you care about the data, encrypt it at the application layer. So it doesn't matter what the link level is. And so from that point of view, the wireless security is not an issue if you follow our advice and say, use SSL, whatever. And our advice is, even if it's not wireless, you shouldn't trust it. So I worry mostly about the mismatch between user expectations and reality and the management and diagnostic aspects of wireless. But there's no question in my mind that the critical mass of our user population is shifting from the desktop wired scenario to Wi-Fi enabled laptops to pocket devices. That center of mass is moving and will continue to move toward the mobility and wireless side of the equation.
But I would submit that there is a security problem, right? Because, I guess you hear a talk also at some point, but proliferation of wireless devices, people can plug in this host, just by plugging things in, right? And making your whole security infrastructure not be able to accommodate that, right? So
well, if you follow our policy, which is if you care about it, you protect it at the app
for example,
level.
if I was following your policy and
Yeah.
yet I would run and plug in an access point somewhere. I mean, I'm not. Your policy says encrypt the data, but I just plug in an access point and allow anybody else without.
Okay, so that's a different class of problem than protecting information. That's protecting the resource from misuse or unauthorized use. And so, for example, for our wireless infrastructure, our security policy is that you have to authenticate to go off campus, but you do not have to authenticate to go on campus. Now, when I talk to CIOs in business about that, they look at me very strangely and say, excuse me? What's the rationale for that? Seems very backwards. Well, the rationale is that when we started doing this, we started with a type policy, and then since it was a captive portal strategy, we kept finding ports that we had to open up so that Windows users could talk to their domain controller so that they could log in, so they could bring up a web browser so they could get to the captive portal to authenticate to use the network. And we kept finding more and more ports that we had to open up. So we then said, well, wait a minute, what problem are we trying to solve here? Are we trying to keep a handful of people on University Avenue from attacking our systems? No, we've got millions of people around the world doing that every day. A few more isn't going to change that equation. Well, are we going to try to keep people on the Ave from getting to the library? No, that'd probably be a good thing. So we said, well, what are we worried about? Well, two things. One, we didn't want to wake up one morning and read in the Seattle Times that an attack had been launched against whitehouse.gov or Amazon from the University of Washington. And secondly, we didn't really want to be an attractive nuisance to let anybody have full internet access to do whatever. So the solution was simple. Let's authenticate on the way out, make it easy for people that just want to get to local resources.
So for many campuses, network access control is useful, but it's by no means a silver bullet. It's not something that we would spend a lot of money on. I mean, it's not the biggest problem that we have. There are a lot of other things that are much more of greater concern. It really is not a new thing with wireless at all.
Network admission control is actually very controversial because if you say to the faculty and staff in a university, good news, we're going to protect you. Oh, by the way, you get to log in one more time during your day. They're not going to look at you as a friend, right? And we're not talking about a homogeneous environment where there's one active directory domain for the entire university, there are hundreds. And so it's not like you can really push that down effectively and avoid the multiple login problem. So, yeah.
So you brought this up as a question, and I want to ask you to try to answer it. What's driving people to ask for surveys as opposed, is it they just want dedicated resources, is it they need better quality of service, can you order the priorities of politics?
I don't know that I can order them effectively, but I think there's an element of all of those. I think, for example, there are people that do not believe that we can deliver the bandwidth and the jitter that they really want to have. You know, if you're talking about gluing supercomputers together and pretending the network is the backplane, you know, the Optoputer project that Larry Samar has, for example, you know, the memory-to-memory access stuff, they get kind of antsy about jitter. So there is a perception that the bandwidth and jitter requirements, QoS type things, can't really be met in a shared layer 3 packet-oriented environment. But I think there's more to it than that. I think there's a lot of concern in that community about predictability and our ability to respond and diagnose problems quickly. Now, never mind the fact that the standard tools of traceroute and ping don't work to solve layer 1 problems. You know, if you go to a Lambda-based network, finding the errant layer 1 component is a whole new adventure too. But I think there's a perception there, my sense anyway, is that there's a backlash against all of the policy enforcement points and the friction points, to use Jim's.
You talk to a physicist or one of the people on our campus and say, you put in ACLs on the campus border, I don't know what they are, and I can't do grid FTP at full speed, and I don't know what's causing that. Forget the fact they didn't set their window size up, but, you know.
Right, and they don't want to live in a world where they have to ask permission to use port 6322. You know, they want to do.
It's friction, it's level of control. It's just, it's not the problem that they're trying to solve. Is the network thing. And if they can just have a network that they can trust and understand, then that's one less thing they have to worry about.
And they have their own IT set.
No.
No, they have expectations that we will support that.
The expectation is this on? Anyway, the expectation is that I run a supercomputer center at USC. The expectation is that as supporting, the mountain lion researcher, that the campus is going to do that thing. That they're the mountain lions, they're going to get fed, they're going to get the things they need.
Mark? The question here is, you give them full access, say through their own personal lambdas or whatever, but you have another client inside, maybe you're not serving that, which is the administration, other items like that, the grading systems, whatever it might be. Those are obviously walled off in a very particular way, aren't they, from the rest of those systems? One is basically going out and uncontrolled, and the other one is inside. Do you allow people to dual home to those systems?
Well, we have a lot of conversations about what is the right paradigm for that sort of problem. We tend not to do a lot of perimeter defense in research universities, but we do have some. And we've always encouraged host or service managers to do host-based access control as they see fit. So if they want to lock down a server to only allow incoming traffic from a particular IP range or a particular set of users or whatever they think is appropriate, we would encourage that. In terms of isolating their traffic from other flavors of traffic, in the old days, we would look at that pretty much from a congestion and capacity planning point of view. So years and years ago, we created what we call a backdoor network between some of our time-sharing clusters to do the file service traffic, because we wanted to keep the interactive traffic and the file service traffic separate, because little packets and big packets don't mix optimally on Ethernet. Now the question is, well, since we have this backdoor network, people are wondering, well, is this a secure network? Can I get away with not worrying about host-based security if I'm just connected to that? And oh, by the way, I'm dual-homed to other things as well. And so does that become a risk to other people that are connected to that backdoor network? And And so the answer is we don't have really good answers to that problem. But it's part of this selective isolation debate.
I would say that most universities do not do a lot of isolation of all those functions because the researcher, because they can't, because the researcher that is going to have the high performance stuff is teaching, and they have to interact with and they also manage their research contracts. So it's application by application sort of security that has to be done. It's not network by network.
Sure.
Sort of security.
We'll put a firewall in front of the student system, but the firewall has to let those same people in, or it's useless. You can't keep, Dr. Schwartz out if Dr. Schwartz runs students. It doesn't work.
Right.
And Dr. Schwartz isn't going to have two computers on his desk.
And a great example is if Dr. Schwartz happens to be an MD,
Yeah,
and
that's
he's
even
providing clinical support for real patients in a hospital, and a minute later he's connecting to our contract and grant system to check on the status of his latest NIH grant, and a minute later he's interacting with students.
So what I'm hearing you say is that I understand the requirements. I mean, you have these people that have multiple personalities in the sense that they function through the day, but you don't have a very good solution for that. But what they're the peak demand that you're trying to satisfy is the glitch-free. I understand what's going on and I control my environment.
No.
Is that taking precedence?
The real problem is we're trying to fix the security problem with a network, and the network isn't the security problem. The security problem is around the operating systems and the systems that are running these things. A system has to be able to build a trust relationship with something or someone else. You aren't going to build that inside a network as if by magic with these little, Deus Ex Machina devices. It doesn't work.
Right. So the fact that we don't have a good solution in the network sense is true, and the question is that a bug or a feature? Is it sufficient to focus on endpoint security to meet that requirement, or are there classes of attacks that you really need to deal with at the network level? And I think there are some. So Slammer, for example, can do a lot of damage.
That's infrastructure protection.
It's infrastructure protection, but it kind of rolls over to other hosts. So people in some departments say, well, I don't want to be on the same subnet as those other guys because I know they don't manage their hosts as well. They attract attacks, and those attacks could have collateral damage for us. So I don't think it's completely black and white. I think we generally have a bias towards endpoint security, but I think we understand that there are some infrastructure level protections that people want, and we need to figure out how to provide them without going crazy in terms of supportability and diagnosability.
In a perfect future, what we need to do is have operating system research done both at the high-performance computing level and the personal applications level, and then there needs to be feedback mechanisms into the network to say, do things to help me protect myself from volume attacks and other things. But the protection itself does not belong at some router that's managed by some anonymous network we need. I mean, the systems themselves have to provide inputs and feedbacks into a network to say, protect me in these kinds of ways, allow these sorts of things. But that knowledge has to come from someplace that's closer to what's going on, not from some arbitrary campus network security officer and all this other stuff.
I had a conversation with the director of security for our medical center yesterday, and he made the comment to me that almost all of meaning his security provisions of his organization have been to create the illusion of security and the ability to pass audits. But they create a false sense of real security, and they don't get to the real issue of having good host management policies, which isn't.
You're escalating another problem, which I think is a very good operating system problem, which is even if the network is basically more flat, so you can do all the things you want to, that these people that have multiple roles and different security requirements based on their role, I don't think it's going to be enough to have application. It doesn't feel like it's going to be enough. The isolation has to happen lower in the stack, even inside the operating system. It can't simply happen at the higher application level.
No, it needs to be we need to have operating system research, and in some sense I blame Microsoft for the lack of that. Windows destroyed the operating system environment in the early 80s. There hasn't been follow-on to Multics and 10X and all these other things since then. There's been this very ubiquitous Microsoft Windows world. That's what happened.
Well,
and I think we missed the boat. There hasn't been an evolution of operating systems and how you build trust fabrics between operating systems and inside of it, and how that relates to a network.
you can ask Dave Clark at MIT for his views on why there are no big system projects in computer science research anymore. He has some interesting ideas on that, but that's off topic for today. To support your earlier thought, though, I agree that you can't do it all at the application level, and a good example of that is file and print traffic that you really need to protect at the OS level, and we're anxiously waiting for IPsec to be easily deployable on a large scale.
I do want to ask a process question. Dave, how much time do we have yet for this session I want to give?
Take about 10 minutes.
Go for it. We'll run over that, but
Okay.
Not a whole
Well, I'll just be real brief, too. I agree with everything Terry said, and we're fellow travelers in this part of the world. The only thing I would add is a few things to point out, like I was mentioning about operating systems. I would take that into, since I run a supercomputer center, I would take that into the high-performance computing space and say that as we're starting to build these large clusters that you see and people going to more and more multi-core and whatnot, I don't see Linux, Solaris, Windows, whatever, being the operating system that you want to run on 5,000, 10,000, 20,000 core, execution unit things. So I think we have to get back to look at what operating systems do from a high-performance computing space as well as from individuals in corporate space. And part of that is driving from what I'm seeing happening with grids. Ken and Carl Kesselman and folks have this argument going back and forth around the authentication things that he's doing in grids. I think part of the problem and the reason those things have come up is we haven't done the research to figure out how grids and things like what Ken is doing fit into operating systems and into networks holistically. I think we need to look at how to build together operating systems and networks and high-performance systems and look at this whole space of operating systems and how they link together. The other thing that's been very interesting is we focus today on protecting our environment, our campus. But it's more likely that the particle physicist at USC is really related to a particle physicist at MIT than he is to the guy next door. Because the guy next door is a quantum physicist or something else. So what we've done is we've built these artificial constructs of networks that don't relate to how people are using them anymore. And I think that's also part of why we're starting to see these the lambdas and the personal lambdas and stuff like that, because you're trying to connect together these groups of researchers or students or whatever that are across the country, across the world, with hundreds of friction devices in between them, that really the friction devices belong between that virtual community and the outside world. So I think the problem is we've got to come up with ways of doing that. Besides that, the other sides of my page here is everything that both Ken and Terry have said. So I'll move on here, and then we can maybe have back and forth.
So I just wanted to say a couple things. First of all, I wanted to say, just for the chatting about a little bit later, I just wanted to say a couple more things. So I'm the IT architect and sort of strategist within a computing organization, again, which is sort of the notion here. A computing organization, the central one at CMU. In terms of other roles, I was one of the first 4 at the CERT back in '88. That's why I have gray hair, or one of the reasons why, yeah. I'm also chair of Internet 2 Security Advisory Group. So in terms of that practitioner and seeing stuff, I mean, I'm really looking forward to talking with a lot of you today. So I've got a number of Me Too kind of anecdotes, but not a whole lot, and then just a couple of points to make also. The first was, as a role of architect, one of my favorite quotes that I'd forgotten and I'll raise back up again was from Bob Morgan, who said that sort of the role of being an IT architect is about making people feel bad about what they're going to do anyway. And so it's mostly about exposing the double-edged sword. And a lot of the things that you've seen here today, or that you saw in those conversations, was, well, it's both good and bad. Well, and I mean, that's what it's all about, is to try and expose what are the good parts and what are the bad parts. But in the end, again, as a practitioner, I got to make this thing work, right? And so I've actually got to deal with this thing in work. So as I listen to other people talk about their projects and whatever, my first thought is generally, well, how am I actually going to use that? So the conversation earlier about the model,
my first thought was, okay, you've got a modeling language. How does that relate to UML? Why is it different? Okay, well, I understand why it's different, and I understand everybody's got a different modeling language. But when it comes down to actually dropping this thing in, how many models am I going to have? How am I going to be able to actually get them to work together? I've got to deal with a lot of things, as we said, that were written 20 years ago, and we've got to try and pull that stuff together. So another anecdote, we also, there was a talk earlier about somebody who turned off grid transfer because they thought it was bad. Well, we essentially did the same thing with WHI's ESM. I think it was yours, right? End system multicast. Somebody said, what happened to multicast? Well, ESM, if you don't know it, too bad. But the point basically is it's about getting machines to help in doing higher layer multicast or to transfer, send fewer copies around. And the behavior of it essentially is it's a growing tree of machines that are talking to each other, right? And the way they're talking to each other looks very much the same. It looks like a botnet, and so it is, absolutely. And the whole point is that behavior is by design. And so it's really hard to come up with simple, not intelligent rules, IDS things, whatever, that are looking for certain kinds of behaviors because there are a lot of desirable aspects of some of those behaviors. So anyway, we learned about that, and now we just have a specific, we don't turn them off anymore. Which is bad, of course. If they do start distributing things, then they're really off to the races. One of the other things I wanted to add is that we actually, in terms of the administration, we're responders more than drivers. Ken mentioned earlier the students that go through our campuses are going to have a lot of expectations, and the marketplace better be able to survive them. As it is today, actually, they're coming with a lot of expectations, and we're having a hard time surviving them. So you talk about whether they come with a Yahoo ID, and then what are we supposed to do about that? Are we supposed to trust it or not? And that's partly where we're coming with some of those ideas of how might we be able to leverage the things that they already know how to do. And it's hard for us to actually do some of that innovation. Let's see if I'm skipping down here. Oh, end-to-end. So we talked a little bit about the end-to-end model, and I think it's not about the ends. It's about all the different things. It's sort of where actually is the network. Today you buy VMware, you got a switch in your machine. Where's the end in that kind of scenario? And I think it's kind of silly, frankly, to talk too much about that stuff. You got to kind of think about there are lots of things going on, and you're just some endpoint or some endpoint, which is a midpoint, and there are things that you have to kind of take that as part of just what we're doing. I want to add that for each of you I want to applaud Microsoft for bringing practitioners here, the people who actually manage the networks and the systems, because for others of you, if you're not doing research and not talking to the people who are doing it, you're missing a point. That doesn't mean that they know what's going on. It's just you're missing a point, and it would be useful to chat with them every now and then about how would they actually use this thing that you're thinking about. A general comment, maybe I'll skip that one. Maybe I'll skip that one too. I talked about that one. That's good. I talked about that one. Sorry, I'm ticking them off. It's very good. Another comment, cert days. If it can be abused, it will be. And I wonder I asked the question earlier, the relationship between configuration management and actual behavioral audit. In security circles, I've sort of proposed this in the past of if a machine is not misbehaving, is it a danger? Is it a bad thing, right? And so this sort of gets to the point of no matter how high the wall, it actually can be breached. I just believe no matter how high the wall, it can be breached. So given the fact that a wall can be breached, do I have to do some monitoring? If I can't completely trust it, what sort of detection and monitoring do I need to do anyway? If my monitoring gets good enough and the latency between detection and remediation is short enough, then how much of that wall do I actually need? So there's kind of this circular argument, and I'm not claiming that that firewalls are bad, right? Firewalls are good. There are really good values of it. Network separation is a really useful tool, but I think that we've really missed the boat on sort of appreciating this notion of if something is not misbehaving, is it really a problem, right? So how much poking around do I actually have to do about vulnerabilities if it's not misbehaving? If I can shorten the latency between, yeah, that machine is vulnerable, but you know what? As soon as that botnet controller bugs it and tries to start launching something, I can shut it down in 3 milliseconds, then maybe I don't have to actually do all of that that forward kind of management. Couple other points. Comment is, I've also heard, and actually I did take a look at the last year's slides, and there were a lot of things I didn't understand, but that's okay. And the comment about, there are a lot of sort of projects about understanding network performance or application performance, and I think that I would claim that it's not actually about the network really from a practitioner standpoint. The network is important, the firewalls are important, but it's all about how users are actually using this thing. When somebody calls on the phone and asks, is the network down, at this point, well, there are so many different views on what that means that it's, I don't know what that means. What do you mean by the network is down? I think that it's all about the workflow. It's about how that person and what they're trying to get to. So you have to actually understand a lot more about the specific path that is being traversed from end to end. And there are absolutely no tools to understand how to do that. Ping is just along the control plane, and you actually can't send packets along the path that their packets will take. Let's see, prediction versus reporting. Well, I guess my comment about that was, can we really predict what is going to fail? So there's a lot of weather reporting kinds of efforts, and I think those are really valuable. I think they're valuable in the same way as firewalls are valuable. But on the other hand, when somebody calls the phone, they don't want to know that the weather is okay. They don't want to know that when they say there's network down, I say, it looks okay to me. They say, well, I couldn't get to this thing. And what happens generally now is you tell them to try it again and see if it's something which is repeatable. If you can tell them 3 times to try it again and it fails every time, well, then maybe you can start to look at figuring out what's going on. So it's not about understanding the condition of the weather. It's about understanding why that person got rained on in the corner of 5th and Broad. Well, I should say it's about both of those things because it is weather too. So a lot of that stuff is kind of coming back to the point of needing to manage transactions, not just components. I think that we need to sort of have an awareness of workflow in addition to state. It's important to be able to respond to that user. Today, I think that there is, that the telemetry in the system is essentially woefully inadequate. I think that there needs to be better understanding about how these diagnostic information or understanding of what's actually going on can interact between layers and between peers in the technology infrastructure, amongst layers and peers in the organization, and also sort of one of the phrases that Terry had coined several years ago is dependencies in seemingly unrelated events. And I think that was the way you coined it. And the notion that oftentimes it's sort of the nature and the flow of not just the presented load from my perspective, it's the rest of the load also that caused the situation to occur. So it may just have been a random X-ray, or it may be that I'm trying to do this ESM at the same time as somebody's doing this other thing, and because those things are coming together at the same time and that I have these problems. Those sort of dependencies are virtually impossible to sort of interact with now. The last point that I would like to make, it is the last point, thank you, and if I have some more coffee, I'll be able to get it done in the next 5 seconds, is that I think that diagnostics and management fundamentally have to become peer-to-peer. And I think that right now, the presentation that we saw this morning, there was a lot of the enterprise, or the object is a system, it's a machine room, it's various other things. And I think that when we start to generate data, when we start to get more of this information available, that you need to be able to give the control about that information back to the people, to the person. And I think that that's something that we really haven't thought about at all. We tend to think about enterprise hierarchy. We tend to think about how does the enterprise control the systems and the data and how it's flowing and firewalls and everything. But in the end, it's about grandma, right? Well, what is her data? What's happening with that? And how can she actually diagnose the problems that she ends up seeing? What access might she have to be able to understand when she gets a 404? Should I just retry, or is it actually that I need to call my ISP? Or something else, can I automate that kind of stuff? For those of you who have assisted your grandmothers or your mothers, or perhaps had your sons help you, those are along that path. So I think that, where did I say this? I lost it. Oh, here it is. So I guess my point was that one of the points on that item were that you have to be able to share data in order to diagnose stuff. And sharing is hard. It's unpredictable. The data is changing. It's dangerous, but it's fundamentally essential. And that's where some of the federation stuff that we've talked about, that's why those efforts are there, is to try and understand how can we negotiate ways to share. And we turn this back into a peer-to-peer kind of situation. How much information can I control? Can I manage my own persona as I present myself to various different things? How is it that I want to interact with the organizations that I'm going to choose to trust with some of my information? How is it that I can choose to be just a peer in the internet and allow the information that I want to get out in a controlled and manageable way? So those are my set of wines.
You can, because we're so running late in the lunch. Some of the tools which actually are effective that you have used, that you think more of those are needed. We heard a whole litany of all these problems and things, but there's something. And how do you monitor things right now? What do you do right now? Is it just a hodgepodge of things that you just put together? Do you write scripts to do that, or is there's something that
all of that on our campus, and I'm sure the others, that we have things that look at net flows. We inside of our layer 2 network, we have things that look at broadcast rates. All of those things you can look for anomaly detections. Terry, I believe, has IDS gear that they're working with. I mean, it has to be a whole set of things. The DarkNet project that Ken was talking about is another thing where you can look at that in a holistic way across the country. All of those things are needed, and I think the research needs to be moved back into that space of how we build these large-scale holistic systems. One thing I had on my list that I didn't mention is that how many, I actually work with researchers on campus to get them packet traces and net flow data. We are very unusual in the fact that we let that happen. I think what we need to do is find ways that the campuses and the researchers get back and actually know each other again, because that's not happening. I think it's going the opposite direction, where the campuses are locking down that data and not giving it back to researchers.
And when you have multiple 10 gig links doing those packet captures is a whole new world.
That's why it's supercomputer center.
Exactly. We all worry about having to have Jim Supercomputer Center just to process the diagnostic information.
Okay, let's take one more question and then go to lunch.
I'm Maurice. I've heard a couple times this come up about the Start Deck project or using anomaly detection or statistics, and it seems pretty much at odds with this notion of dependability, right? So if I'm a protocol designer and I want to make my new protocol and it doesn't work, and I ask you why, and you tell me it's because it kind of looks like this traffic that came out of the Ukraine, it's very difficult for me to reason about what's going to work and what's not going to work. And so I'm actually going to go on the limb and say I think this might be fundamentally the wrong approach, and it kind of failed in operating systems in the 80s. So we're saying, okay, we're going to kind of figure out if this is normal, and if it's not normal, we're going to smack you, as opposed to saying this is accepted, very rigidly defined. If you obey this, you're okay. No more questions asked. If you don't, then we're going to stop you. And I think that a more manageable network is one that you can kind of reason about from the onset, instead of kind of hope that this soft state blesses you.
I absolutely agree with you. Our campus security officer would say, I don't want to tell you that information because that's proprietary to me, and if I told you, then you would know how to get around it. I disagree with that, but I agree with you 100%.
Yeah, I think that you'll find us basically saying we want this stuff open, and we want it so that we can reason without a whole lot of funkiness. And that's partly what Terry said about when you've got all this software defining stuff, you have no idea kind of what's going on anymore. So it's a matter of being able to, the darknet stuff is really about sharing darknet information, which is unused IP address space, and just sort of seeing what's going on there. So it's not about turning off somebody's experiment at all.
It's not a common set of net flows where everybody shares net flows. It's where you see who's attacking dark.
But I wanted to come back to the comment over here just to say that it's my guess that there are more loops that I described. The firewall versus behavioral detection versus shortness, the latency that then feeds back to if I can make these other things better, then there's a balance between those three. And I have to figure that out for myself. But I think that there may be more of those sort of balancing acts that may exist. But right now, in the market or as a practitioner, all we have are the tools that people give us. And the tools that are, well, I do my network management stuff, yeah, I do IDS, yeah, I do that, but I don't really have a good way of reasoning about how do these things relate to each other and what would be better to start to think about. This is just this aspect coming at it from that way. And you know what, if I started this way instead and I had these tools work well, I wouldn't have to do that sort of nasty thing.
So is it fair to say that today what you have is potentially a good manageability of the boxes, but not manageability between, and or relationship between them, and that's not the one that's not really...
I would say we have, conceptually, we sort of know how to do manageability of the boxes. I would not claim that everybody has good manageability of the boxes, but I think that's something which is relatively well known. You can do lots better. That's what all these tools are that we saw earlier. So I think we need to do better with that stuff. But my comment really is it's more about the behavioral stuff. I would like to see a lot more understanding of the behavioral of these things to be able to come back and decide, as it was said earlier, a lot of problems that you have are actually configuration problems. And you can shoot those by actually doing better configuration management. On the other hand, you can detect most of them behaviorally also.
So when you talk about manageability of the boxes, are you talking about in-systems, desktops?
More generic, even
Yeah,
for example,
all
manageability of DHCP servers and things like that. So.
Right. So I think we know how to manage some of our key services, but we have almost 100,000 hosts on our network, of which maybe 5,000 are managed. Is running XP SP2 enough to qualify for being a well-managed box?
Yeah, and if you're running VMware on top of it with God knows what inside of that, with a virtual switch and firing packets out, how well managed is that necessarily?
I was just keying off your own point. I was just sort of saying that, what you're saying to me is what I'm internalizing is that when you look at the system, you have to have some expert to look at all these things that are coming out and do the correlation. You don't have enough tools to do that for you.
And in some cases, we don't have the data we need from the devices to really be able to be effective in that space. And as far as behavioral stuff, I think there could be niches in industries where all they run is Exchange and SAP, and it's easy to see anomalies. But that's hopeless in our world.